All right, in case you're wondering what subtopics we're covering, they're right here, guys, in the top. 1.4, 1.5, 1.6, 1.7, 1.9. These are properties that we already talked about earlier in notes 2. They're just re-emphasized and put in here nice and neat with a few new properties. Try direct substitution, new for you, direct substitution. So these are the new ones, and the rest are from notes 2. And yeah. So here it is. Here's our theorem number 2, and relax. We're not calling these theorems. We're just, let's see, polynomials and rational functions. And you have all this, and it says any polynomial function and C is any real number, then blah, 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 blah. If f of x and then g of x are polynomials and C is any real numbers, then blah. So what does all this mean? All this means is try direct substitution first. That's all it means, guys. All that mumbo jumbo just means try direct substitution first, if you can. So let's see. Let's see if we can use theorem 2. Look at example 1. And it just says try direct substitution first. Limit as x approaches 3. I don't have it's not a rational function. I can just do direct substitution, and I can go 3 squared, 2 minus 3. There it is. 3 squared is 9. 2 minus 3 is negative 1. So negative 9. So this limit is just negative 9. And that's all it is, guys. Pretty straightforward. What do you guys think? Yeah, not that bad. So let's try this one down here, letter B. As long as you don't get a 0 in the denominator, and you don't, 2 plus 2 is 4, so we're good. Do direct substitution. 2 squared plus 2 times 2 plus 4 over 2 plus 2. So let's see. 4 plus 4 plus 4 over 4. There's 3 4s in the top, so this has to be 3. Or you can do 4 plus 4 plus 4, which is 12 divided by 4, and that's 3. And that's it. That's pretty easy, guys. Yeah, just try direct substitution. All right, now look, check it out. I think those are straightforward. What if we have a function like this, and they ask you to find the limit as x approaches 0? Can we do direct substitution with this? Well, if you try direct substitution, look what happens. You get 0 over square root of 1 minus 1, 0 over 0. By the way, 0 over 0 is not a thing, but for now, we'll go ahead and allow it for now, because we're rookies. 0 over 0 is not a thing. You can't say, oh, that's a 1 because you got something over something. No. So this is, we cannot do direct substitution. So put in there, we can't do direct. We can't do direct sub. So what are we going to do? Use your calculators, guys. So here's what I'm going to do. I'm going to take my calculator, and all y'all's calculators are the same as mine. The only difference is mine is in color. So click on the y equals. So let me clear mine. And then you're going to push alpha y equals enter to get the little fraction. And then what am I going to put in the top? I'm going to put x. So put x. And on the bottom, I'm going to put square root. What was it? X plus 1 or x minus 1? X plus 1. And then go out of there and then put minus 1. Does everyone have that? Okay. I'm going to wait. Make sure that you're attempting it, guys. Click on table set. So push the second button and window. And you're going to get this. Go to independent and put ask. All right, here we go. Is everyone okay so far? Second table. Oh, I'm going to delete mine. You should have nothing on yours. And I'm going to start with negative 0.2. So I'm going to go negative 0.2, negative 0.2, enter. And I get 1.8944. Put that in there. 1.8944. And all I'm doing is getting closer and closer to 0, guys. This is coming from the left. See? Negative 0.1. So negative 0.1. Put 1.9487. 1.9487. Continue, negative 0.01. Negative 0.01. 1.995. 1.995. Negative 0.001. Negative 0.001. 1.9995. It does look like I'm approaching something. As x gets closer and closer to 0 from the left, it looks like your y value is approaching what value? It looks like it's approaching 2. So I'm going to write this on the left-hand side. I'm going to go limit as x approaches 0 from the left of this function, x over square root of x plus 1 minus 1. Make sure that minus 1 is outside the square root. It looks like it's approaching 2. Let me see what happens as you approach 0 from the right-hand side. So I'm going to go back to my calculator. I'm going to clear everything. Just push delete, 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 delete. And I'm going to do the same thing, but from the right. So let's see. If I'm approaching from the right-hand side, so 0.2, enter. Put that number in there, 2.095. 0.1, enter. Type that number in there, 2.09542, 2.0488. So let me know. 2. I already forgot it. Short-term memory. What was that at 0.2? 0.095. What was it at 0.1? 0.488. 0.01, guys. So put 0.01, 0.01. Enter. 2.005. 2.005 and 0.001. 0.001. 2.3 zeros in front with a 5. 2.0005. Of course, if you get more and more accurate, check it out. Don't be confused. If you put 0, it's going to say error. See? But let's say if I put 0.000001, let's see what it says. It says 2, but it really isn't 2. It's really like 1 point. Look at that. 2.00000004. It's really that. But of course, obviously that's close enough to 2, so it just says 2. So check it out. So from the right-hand side, I'm going to write limit as x approaches 0 from the right-hand side of this function, x over square root of x minus one on the outside equals 2. So from the left and the right, do they approach the same y value? So we're going to say, we can conclude that the limit as x approaches 0 for this function is 2. And there it is. Could we have done this algebraically, guys? What do you guys think with your algebra skills? Yeah, you could have also looked at a graph. I think you could have also looked at a graph. All right, I want to show you guys the algebraic manipulation. All right, what's making this hard? So don't worry, I'm still on the front page, guys. I'm just doing this algebraically. Giant parenthesis or giant bracket. All right, guys, follow along real quick. Square root of x plus 1 minus 1. What's making this hard to evaluate, the numerator or the denominator? The what? The numerator is just an x. So the denominator is making it hard, right? So we're going to multiply by the conjugate. This is why your algebra skills are important. So here we go. I'm going to change my color to, like, I think it's like a violet. So square root of x plus 1 over square root of x plus 1 plus 1. Chav, I have no idea why you're multiplying it by the conjugate. Can you tell me why? Yes. This is similar to the difference of squares. And I'm going to have that middle term with the nasty square root canceled out. What happened, miss? Oh, everything okay? Oh, yeah, there is a big fly. I've seen it. It's like a horse fly or something. All right, this is like a 1. Anytime you multiply anything by 1, does it change? No, so it doesn't change the value of this, so it still stays the same. The expression is still the same. So check it out, guys. When I do this, I'm going to write equals limit as x approaches 0. The numerator stays the same, so leave it like this. X parenthesis square root of x plus 1, close it, over. But the denominator, this is like the difference of squares, like. So square root times square root, the square root goes away, x plus 1. Negative 1 times the positive 1, minus 1. Look what zeroes out first. The 1s zero out. Now that I've zeroed out the 1s, what can I cancel out? The x. Now I can cancel out the x. Now can I do direct substitution? Now you can. 0, the square root of 0 plus 1, the square root of 1 is 1. 1 plus 1? 2. And look, you get the same answer. That's called algebraic manipulation, guys. We will get really good at that. How do we feel? I know it's not the most exciting stuff in the world, but hopefully.
How did you know that was like? How did you know that was a conjugate? Or like basically, what is a conjugate?
A conjugate just means, like, if I tell you what's the conjugate of a plus bi, the conjugate of a plus bi is a minus bi. And I want you to notice that it looks like the difference of squares. If I were to tell you a squared minus b squared, that's a plus b, a minus b, see? So we just multiply by whatever is giving us a hard time. So I have a minus there, so I change it to a plus. And I know that the middle stuff is going to go away, so I just have to worry about this guy times this guy and this guy times this guy. Watch, I'll show you. So if I had something like a minus b times a plus b, this is just a side note, guys. A times a squared, a times b plus ab, negative b times a minus ab, negative b times b minus b squared. Look at the middle terms, how they just cancel out. And you get a squared minus b squared. So that's why I did the difference of squares here. That's why I did it square root of x plus 1 plus 1, because I wanted the middle stuff to cancel out, the ugly stuff. If I would have had a minus in the front of the plus 1, it would have been minus 2 square root of x plus 1, because you have 2 of those. But I didn't want that. Does that make sense? You can say no if it doesn't make sense.
Yeah.
So yeah,
That part makes sense. It's just I don't see it. Like, I'm not seeing where that happened to you.
Okay, so let's say, okay, don't write this down, just listen, guys. So we need a hack. This is a hack. I cannot do direct substitution, because if I plug in a 0, I get a 0 on the bottom, right? And I'm like, okay, well, what can I do to make it the same? You can multiply by whatever you want. Let's say I chose, don't write this down because it's wrong. Let's say I chose square root of x plus 1, and I think that's a minus 1? Minus 1 over square root of x plus 1 minus 1. If I would have done that, I would not have gotten this expression, because I would have distributed like this. Let me erase all this stuff here. Look, watch. Come on, buddy. Don't write this down, guys. Just listen. And I know what you're saying, because we're rookies. So right now you're together like, I don't understand why you did that. So if I would have done this, square root of x plus 1 minus 1 times square root of x plus 1 minus 1. Look, I would have had the nasty stuff. So that right there is x plus 1. But then I would have gone like this, and I would have had one of those minus square root of x plus 1. And then I would have gone like that, and I would have another one, square root of x plus 1. And then negative 1 times negative 1 plus 1. Look at that in the middle. It doesn't simplify anything. If anything, I made it harder. Oh, I guess 1 plus 1 is 2, so you could have put those together. But I still have that. And if I plug in a 0 in there, I'm still going to get like 0 and then 1 plus 1. Like, see, it doesn't make any sense. Like, let me see. Hold on. What did I do? X plus 1. Oh, yeah. So let's say I want to simplify this. X minus 2 square root of x plus 1 plus 1. Let's see. If I plug in a 0, 0 minus 2 plus 1, and I still get that minus 1, and then I still have, did I do something wrong? That should have been a plus 2, no? 1 plus 1, that's a plus 2. I'm doing this plus 1, guys, here, and this plus 1. That's a plus 2, so I would have had this, and then look, I would have just had 0, but that's in the denominator. Can you divide by a 0? It doesn't make it any easier. Like, I still have a 0 in the denominator. Does that make sense? So I know you guys are rookies, so you guys are saying, I don't understand how you got that. So how do we do this, guys? You got to multiply this expression by something that's going to cancel out that square root. So I can get something in the denominator that is not a 0. So to do that, you do it by multiplying by the conjugate. And then when you do that, when you multiply by the conjugate, so here you go. You still haven't solved for anything, so you still write the word limit as x approaches 0. Now the numerator, that times that, you leave it alone. Square root of x plus 1 plus 1 over, and in the denominator, that looks like the difference of squares. X plus 1 and then minus 1, because the middle stuff is going to cancel out, right? You know what I say when I say the middle stuff is going to cancel out? Okay, no? Okay. Let me show you that. So, Chav, what do you mean by the middle stuff is going to cancel out? Here's what I mean, guys. Square root of x plus 1 minus 1 times square root of x plus 1 plus 1. Look, when I multiply them, square root of x plus 1 times square root of x plus 1, that's just x plus 1. Square root of x plus 1 times the positive 1 plus square root of x plus 1. Negative 1 times square root of x plus 1 minus square root of x plus 1. Negative 1 times positive 1 minus 1. Look at this, guys. This in the middle. It zeroes out. See? And then you get a 1 here and a negative 1 there, and those zero out. Do you guys see that? So you just have an x by itself. So these zero out. And now that I have, look, this is a product in the top. This is x times that. Divided by product and quotient. Multiplying and dividing are inverse operations. So now you can cancel out these x's. Now I don't got a denominator. Now that I don't have a denominator, now I can do direct substitution. Do you guys see that? And now I just do direct substitution. 1 plus, what is it? 0. 0 plus 1 is 1. The square root of 1 is 1. 1 plus 1 is 2. And you get your 2. Did I answer your question, Ms. Rowe? Okay. Okay. Sorry, guys, if we explain that.
I think it's just whenever you like skip steps and then like you assume that we know, I'm like, no, I don't know. Like
Okay.
that last part right there is like where I was lost.
Okay. So I'll try not to skip steps. All right, here we go, guys. We got another one. Like DJ Khaled says. Do you guys know who DJ Khaled is? Maybe you guys. Okay. I think I'm reaching the point of like maybe Generation Zers don't know. Okay, I'll stop anyways. All right. Limit as x approaches 0 of sine x over x. You guys ready? Yeah, there's a giant fly, I know. Here we go. Take your calculator, click on y equals, put sine x over x. So alpha y equals, to get that little fraction thing, sine x over x. Maybe push graph, maybe you can look at a graph, but I don't want to look at a graph. Click on window, not a window, second table, and I'm going to delete all those values. And I'm going to put these values, negative 0.2, negative 0.1, negative 0.01, negative 0.001. So let's do that. Negative 0.2, negative 0.1, negative 0.01, negative 0.001. Be careful, it says 1, it's not 1. So look, how do you find out what that number really is? You hover above it. 0.999999. 4 digits after the decimal is enough. 0.999999. As a matter of fact, on this one, I'm going to put 5 digits. 1, 2, 3, 4, 5. Put 5 digits on this one. 0.9933. So you guys hook me up. Let's see. 0.99334. 0.99334. 0.99334. What's the next one? Give me one more digit. 3. Okay, what's the next one? 0.9999. What's that fifth digit? 8. All right, and this one I'm assuming is 0.99999. I'm assuming? Yes? Guys, let me know, because I can't. Guys, focus. Remember why we're here. We want to qualify. We want to make sure that you guys get college credit and are getting a quality education. Are we okay so far? Okay, here we go. I'm going to do the same thing. This is an even function, so you're going to, it's going to be symmetric, so you're probably going to get the same answers. 0.2, 0.01, 0.1, sorry. 0.1, 0.01, 0.001. Do you get the same values? Yeah, it should be because it's symmetric on the y-axis. So I think you get 0.99334. Let me know if it's not right. 0.99833, 0.99998, and 0.99999. If I'm approaching, okay, let me do the left one first. Limit as x approaches 0 from the left of sine x over x. What does it look like it's approaching? 1. Limit as x approaches 0 from the right of sine x over x. What does that look like it's approaching? 1. So what can we conclude about the limit as x approaches 0 of sine x over x? It's 1. That's a special limit, guys. You're going to have to know that one. These are my special limits down here. And then I have variations of it. So it could be like this, guys. Look, watch. Check it out. Limit as x approaches 0, sine of 5x over 5x. What do you think this is? Take a guess. 1. Good job. Limit as x approaches 0, sine happy face x over happy face x will always equal 1. What's the reciprocal of 1? 1. So if you see limit as x approaches 0 of happy face x over sine happy face x, this is also 1. Man, Chavez is making such a big deal about this one because it comes out over and over and over again. Cool? Now, don't get tricked. Look, notice I already said don't get tricked, so you should be on the alert. Notice that this one is approaching infinity. What do you think this one is? Do you think that one's 1 also? Take a guess. What do you think it is? Just think about it for a little bit. It's not even hardcore. No.
Okay. 0?
0. Can you explain why?
Because it's like, is it the opposite, basically? Like I thought. No, it was just
All right.
like this.
Don't worry. You're probably on the verge of getting it right. All right. Okay, guys, I need everyone to listen, so put your pencils down. Okay. Sin x, you guys all took pre-cal. Sin x just goes between -1 and 1, yes or no? So look what happens as the denominator gets bigger. Don't write this down, just listen. 1 divided by 1 is 1. 1 divided by 10 is 0.1. 1 divided by 100 is 0.01. 1 divided by 1,000 is 0.001. So notice what happens. I have sin x over x, and x is approaching infinity. So the top is just going between -1 and 1, but the denominator is getting larger and larger and larger. So that means the output keeps getting smaller and smaller. It keeps approaching 0. So that means the output, like if I were to put this in the calculator, you'd probably see it something like this. And it's just going back and forth, back and forth, back and forth, but getting closer and closer to 0. Does that make sense? And of course, it's doing something here. It approaches 1 there, but it's going something like that. And that's sometimes called steady state in medical and other stuff. But does that make sense to you guys?
Can you say that again?
Yes. Oh, look, all you got to know is this. Sin x goes between -1 and 1. X is getting larger in the bottom. Something divided by big is going to be 0. Always. Something divided by big, if the bottom is bigger than the something. Look, 1 divided by 1, look, it's right here. 1 divided by 1 is 1. 1 divided by 10 is 0.1. 1 divided by 100 is 0.01. 1 divided by 1,000 is 0.001. I'm just getting closer and closer to 0.
I see the vision.
Okay. All right. Yeah, don't be careful with the word opposite, because opposite means if it's positive, it's negative. If it's negative, it's positive. All right. All right, guys, real quick. This one, we are going to talk about it a lot, especially when we start doing derivations. It could look like this. It doesn't have to look exactly like that. It could be limit as x approaches 0. It could be cosine x minus 1 over x, and that is still 0. That one you cannot do the reciprocal, because the reciprocal of 0 is undefined. Does that make sense? Okay. And there it is, guys. It doesn't have to be the letter x. It could be the letter h, as long as it's an h. Limit as h approaches 0. Notice I wrote h. 1 minus cosine of h over h. That is still 0. Cool or not cool? Yeah, those are just properties to know. We won't really talk about this one much. It is pretty important also, but we'll use that later on. So the first two you got to know, cold. So those are because they come out a lot in properties. Those are properties. Why is what, number 2? Why is this one 0? Top. Oh, because you don't care about how the top looks. You don't care about the signs of the top. As long as it's like, if you factor out a negative, you're still approaching 0. If you were to graph this graph, matter of fact, let's do it. Let's graph 1 minus cosine x over x. So look, guys, here it is. I'm going to graph 1 minus cosine x over x. And check it out. I'm just going to go window. I'm going to go negative pi to pi. And we just care about right on the x-axis, -1 or 1. That's fine. You're going to see a nice graph. Look at that. It looks like, look, it's missing a pixel if you look closely. If you look closely, because you're not defined at 0. But look how this graph, as you approach the origin, what does that y value look like to you? 0. Now look, check it out. I'm going to go and change the polarity of the top. I'm going to do the same thing, but now this time I'm going to write cosine x. Cosine x, and it's going to be the same thing, guys. Look at this. -1 over x. And look at the red graph. Same thing. I would not call it inverse, because inverse means, but notice that I'm still applying, like I approach 0, it's still 0. Do you see that? Cool or not cool, guys? We're okay? Okay. All right. So now we know. All right, here we go, guys. Now we know limit as x approaches 0, sine x over x is 1, and 1 minus cosine x over x is 0. And as long as x approaches what? 0. X has to approach 0 for those guys. All right, Chav, when am I going to use it? Here we go. Look at this one. Look at example 4. And maybe you can add this one to your special limits. I know, guys, we'll be done in a little bit. All right, guys, focus, focus, focus. Okay. Can I do the first thing you do, first order? Can you do direct substitution on this one? Yes or no?
Yes. No, because 0 can't be at the bottom.
Good. 0 cannot be in the bottom, guys. Guys, wake up, because some of you guys are still asleep. 0 cannot be in the bottom. You can't divide by 0. If you do, you're going to win the Nobel Prize, because no one's ever done it before. And it's not possible, period. So don't attempt to divide by 0. You can't divide by 0, guys. Are we clear? So we have to do something else. The only hack you got to do a hack. The only hack you know 2 hacks, but the only hack that's meaningful is this one. Limit as x approaches 0 of sine x over x equals 1. That's the only hack you know. And I guess you can say the reciprocal of this or the inverse of this, x over sine x, that's also still 1. Those are the only hacks. That's all you know right now. Luckily for you and I, tan x, we all took pre-cal. Tan x is the same thing as what over what? Sine over cosine. Sine x over cosine. Yes or no? So here we go. I'm going to write the word limit as x approaches 0. And I'm going to write tan x over x equals, and I continue to write the word limit because I haven't solved it yet. Limit as x approaches 0 of what? I'm going to replace tan x with sine x over cosine x over x. I'm going to rewrite it. I'm going to put that x next to the cosine x. So I'm going to write limit as x approaches 0 of sine x over x cosine x. Have I lost anyone? All I did was keep, change, flip. Bring the x next to that cosine x. It's like x over 1. Keep, change, flip. Sine x over cosine x times 1 over x. That x goes next to that cosine x. Are we okay? Okay, here we go. This is all I know, guys. So now it comes out to like chemistry when you're balancing stuff. Limit as x approaches 0. I'm going to put a giant parenthesis because all this is inside my limit. And I'm going to write it like this. Sine x over x times 1 over cosine x. And I'm going to close my parentheses. Is that the same thing as this expression? Yes. And now look, I can use my properties of limits. Sine x over x, that is just what? 1. Times, what's cosine of 0? 1. Cosine of 0 is 1, so I can do direct substitution on that. So I have like 1 times 1. What's 1 times 1? There it is. You got it. If you want to add this, under special formulas, you can, but you can derive it. You can go back to your special formulas and you can say limit as x approaches 0 of tan, open parenthesis, happy face x over happy face x. You guys like happy faces? I mean, I can use something else, maybe a triangle for you happy face haters. Okay. For the happy face haters, tan triangle x over triangle x equals 1. For that, because there's some people that are happy face haters. They don't want to see happy faces. They don't want to see the world happy. They want to see the world burn. I'm kidding, guys. I'm kidding. That's a joke. The same can be said for the reciprocal or quote-unquote inverse of this. X over tan x is still 1. Well, as long as x approaches 0. Are we okay? Okay, here we go. All right, look at example 5. Can I do direct substitution? No, why can't I not do direct substitution? All right, big hint. Big hint. I just want to, guys, focus real quick. If you get 0 over 0, there's a rule. It's called L'Hopital's rule. You do not know how to use it because it requires derivatives, and we're not there yet. If you try to get tutoring from, I know SAISD has tutoring help with College Station, those College Station, they're just students. They're not teachers. Those students are going to tell you to use L'Hopital's rule. Just tell them, we haven't covered that yet. I don't recommend you go to if you need help, ask me directly or ask a professor. I don't recommend you ask a student at any university. Because they're just students themselves. They're not experts at it. So here we go. If you get 0 over 0, 99% chance that it has a limit. It's very rare that it does not. Are we clear? All right, so if I can't do direct substitution, what do I got to do? What do you notice about the numerator? It's the difference of what? So if it's the difference of squares, what do I have in the numerator then? X plus 1, x minus 1. This is a product all over x minus 1. What do you notice about your factors? You can cancel out. Which factor can you cancel out? Now that I've canceled out my x minus 1 factor, what can I do direct substitution now? What's 1 plus 1? There you go. Do you see how we did it? Look at example 6, letter A. Can I do direct substitution? No, it's the same as example 5. I just switched them. So again, what are you going to do? Factor out. Which one? This time the denominator, x plus 1, x minus 1. As long as you don't get a 0 in the denominator, what can I cancel out? The x minus 1s. Now that I've canceled those out, can I do direct substitution? Yes, the numerator is still a 1 because you have a 1 on the top. What's 1 plus 1? There it is, 1/2. Do you guys see how we did it? Don't worry, we'll slow down. Don't worry, we'll slow down. We're slowing down right now. All right, look at letter B. Can I do direct substitution on letter B? No. So I have to do what? Let me see. Notice that all 4 terms, the 2 terms on the top and the 2 terms on the bottom, they all have a what? An x squared. Do you guys notice that? Can I factor out an x squared from both terms on the top and the bottom? For all 4 terms? Yes. So here it is. X squared factored out. 3x plus 20, close, over. And I know you can factor out a 5 in the bottom, but don't, because I want to cancel that x squared out. So factor out that x squared, and look what you have now. 5x squared minus 10, close. Now what cancels out? The x squares, because you have a product dividing by that x squared there. Multiplying and dividing are inverse operations. Now can I do direct substitution? What am I going to get? 20 over negative 10. And what's that reduced to? Negative 2. Do you see how we're doing it, guys? Ask me, Martinez, what's up?
No, I figured it out.
You figured it out?
I'm just a little behind.
No, we're good. We're good. It's a little warm in here, guys. Well, it's because of all the heat from the laptop. The laptop's doing a lot. It's outputting video. It's recording, and I'm annotating. So not every I got my laptop already, by the way, but I just don't have the software. So why bring it if I don't have my software, you know? Yeah, I guess, to show you guys. All right. Here we go. Yeah, how am I going to record, right? So, what? That would look bad. Oh, okay. I'll bring it. All right, here we go, guys. Can I do direct substitution on this one? No, I don't know if you remember, but if you look at your pre-count notes, we simplified this expression way back then. I know, because I made the notes. So here we go. I need a common denominator in the numerator. So I'm going to multiply the right term by 2 plus x over 2 plus x. I'm going to multiply the left term by 2 over 2. Guys, I don't want you to become a robot. Why am I doing this? 2 plus x over 2 plus x is 1, so you haven't changed the value of anything. You're just changing the expression itself, but you haven't changed the value of anything. Cool or not cool? All right, here we go. Equals limit, because you haven't evaluated it yet, as x approaches 0, giant parenthesis, you're going to have 2 over, and I wouldn't distribute it, not yet at least, like that, minus, and then see 1 times 2 plus x is just 2 plus x, over 2, parenthesis, 2 plus x, close it, over x. And for now, I'll go ahead and show all the little detail steps. My denominators and the numerators are the same. put a parenthesis in the top so you don't mess up with when distributing the negative. And I'm going to bring the x up. Limit. Okay, I'll slow down. As x approaches 0, giant parenthesis, 2 minus x over 2 parentheses, 2 plus x, close it, x. Close the giant parenthesis. Is anyone confused how I got here, guys? Dime.
How come you only did it? Oh,
No, tell me. Dime.
No, I was going to ask why you only did it to the top, but I did the same thing.
All I do was keep change flip, guys. All I do is keep change flip. That's like x over 1, so it's like multiplying by 1 over x. So it's going to go with the 2 plus, the product of 2 of 2 plus x. Are we okay, guys? All right, here we go. What do I zero out in the numerator? The 2 minus 2, they zero out, guys. So zero them out. Now that you have zeroed out, what cancels next? The x's. One of these with one of these. Now can I do direct substitution? Yes, you no longer get a 0 in the denominator. You have a negative 1 in the numerator, so don't freak out. You got the negative 1, that's right there. Over, let's see, x is approaching 0. What's 2 times 2? So the answer is negative 1/4. Are we okay? Do we feel okay? All right. Look at letter D. You guys ready? I'm going to go slow with this one. Just by looking at it, what do you think the answer is? Is it 1? The only hack you know. What's the only hack I know, guys? You got to say limit as x approaches 0. Limit as x approaches 0 of what over what? Sine, I'm going to say happy face x. Over happy face x equals 1. We're about to use our happy face x formula or hack. I have, if you want to put parentheses in here, you can to save it. So here we go. That's not 1. So limit as x approaches 0 of sine of 2x over x. And I'm going to change my colors. So if you have colored pencils, here's where it comes into handy. So right now, I don't know the answer, but look what this says. So look at your hack. If you have a colored pencil or a colored pen, now's the time to take that out. You guys ready? What do I need in the bottom for this to equal 1? A 2. So let me say it again. You're right. You're right. Everyone's right. What do I need in the denominator for this to be a 1? You said it. Say it again. A 2. But this is magic. I can't just add 2 there. This is just like in chemistry. If I put a 2 in the bottom, I got to put a 1 in the top. A 2 in the top. Now it's balanced. And now, this right here that I'm circling, this is all a product. This is just, that 2 there is that 2. And then what's sine of 2x over 2x? 1. What's 2 times 1? There it is. You got it. Do you see how we did it, guys? Are we okay? You're going to get another opportunity in letter F. Don't worry. And letter G is a pretty tough one. All right, look at letter E. Can I do direct substitution? No, but something should be ringing a bell from this x cubed minus 125. 5 to the third power, is 5 to the third power 125? So this is the difference of cubes. Do you remember the difference of cubes formula? No? Okay, I'm going to write it here for you guys. A cubed minus b cubed equals, parenthesis, a minus b, close, open, a squared plus ab plus b squared. That's the difference of cubes formula. If you were to distribute that, you would get a cubed minus b cubed. Are we okay? Okay. You guys already told, did you guys already tell me that we can't do direct substitution? Okay. Why can't I do direct substitution? You get a 0 in the denominator, and do you get 0 over 0? Yeah, so you're going to have a limit. Remember what we said. If you get 0 over 0, 99% chance it's going to have a limit. Here we go. I'm going to write limit as x approaches 5. The numerator is the difference of squares, so I'm just going to use my top formula up there. X minus 5, close, open. And now it says a squared, so that's x squared plus, this is ab, so that the b was a 5, so it's going to be plus 5x plus, and it says b squared, the b was a 5, so 25. All this is over x minus 5. Is anyone super confused? Okay. What can I cancel out, guys? X minus 5. X minus 5, 0, cancel out. Now can I do direct substitution? Yes. 5 squared is 25. 5 times 5 is 25 plus another 25. What's that? So this limit is 75. How do you feel? For letter G, we're going to need your A game for letter G. Letter F. Can I do direct substitution? No, why not? Yeah, you get a 0 in the denominator. Do you guys see that? You also get a 0 in the numerator. Sign of 0 is 0, by the way. And I know this is not the most exciting stuff in the world, but here we go. The hack. The only hack you guys know, limit as x approaches 0. And for this one, I'm going to write it as sin x over x equals 1. That's the only hack you know right now. So here we go. I'm going to write limit. As x approaches 0. And I'm going to factor out. So I'm going to have sin x over. And in the bottom, what can I factor out? X parenthesis 2x minus 1. Close it. So hopefully you're seeing now what you're going to do. Equals, write the word limit. And because you're going to have two different terms, put a giant parenthesis. We're going to multiply those terms using our properties here, right? So I'm going to group that x with the sin x. So I'm going to go sin x over x times, now I'm going to have 1 over 2x minus 1. Close it. What's the limit as x approaches 0 for sin x over x? 1. 1 times, can I do direct substitution with the 1 over 2x minus 1? Yeah. 2 times 0 is 0. 0 minus 1 is negative 1. What's 1 divided by negative 1? Negative 1. What's 1 times negative 1? Negative 1. So my limit is negative 1. See? Is it getting easier, guys? Okay. All right, I need your A game for letter G, so take a 30-second break, get up really fast, stretch, throw some air punches, but I need your A game for letter G, so get up real quick, guys. Yeah, I wish I could have standing. Does the standing desk help? I think they do too. Well, especially if you're tired. Did you work last night? Up to what time? 9? Damn. From 12 p.m. to 9? That's a lot of hours. At least you're going to have a big check. I missed. Did they know you're a kid? You should. Are you putting in like 30 hours a week or something? If you can do 15 hours, even better. But yeah, guys, you guys are going to be working all your life, so try not to work so much. All right, here we go. Here we go, guys. I need your A game on this one. Letter G, the only hack you know. You only know one hack, and I guess two hacks. Let's see. Okay, I can already see this is going to be a tan one. So you only know two hacks, technically. The only hacks you know is limit as x approaches 0 of sin x over x equals 1, or limit as x approaches 0 of tan x over x equals 1. Those are the two that you know. We're going to use the tan one. Chow, how do you know that we're going to use the tan one? Because I took pre-cal, and so did you, and I see that I have 1 minus secant squared. I'm going to get rid of that. So do you remember the Valentine's formula? What is it? Yeah, you guys, guys, wake up. Cosine squared plus sine squared equals 1. Yay or nay? I'm going to get this to be 1 minus secant squared. The only way I can get a secant squared out of the cosine squared plus sine squared equals 1 out of the Valentine's formula is if I divide everything by cosine squared. 1 over cosine is secant. Does that make sense? So I'm going to take this dude, and I'm going to go divide by cosine squared, divide by cosine squared, divide by cosine squared. And when you do that, here's what you get. You're going to get 1 plus sine squared over cosine squared. That's a tan, but since they're both being squared, 1 plus tan squared equals secant squared. Do you guys see that? I'm going to slow down. I have a 1 minus secant squared. So the only way to get 1 minus secant squared is if I move this to the left, but then I have to move the tan squared to the right of the equal sign. So 1 minus secant squared theta equals negative tan squared theta. This is what I need. That's the tool that I need on this one. Are we ready? Here we go. You guys ready? The whole point, Chav, I don't understand what you're doing or why you're doing. You can't do direct substitution. You get 0 over 0. And the only hacks you know is sin x over x and tan x over x. There's not going to be a sign on this one, so you want the tan because you get a tan in there. So here we go. Limit as x approaches 0. And for now, you don't need a parenthesis because I'm just going to substitute the 1 minus secant squared 4x for tan. Negative tan, and I got to keep the argument, negative tan squared of 4x over, and then I'm going to square this. What's 6 times 6? 36x squared. Are those two expressions equivalent? The one on the top and the one on the bottom? When I say bottom, I mean this one. Are they the same, guys? Yeah, they're the same. Look, you just saw it. 1 minus secant squared is negative tan squared. Are we okay so far? All right, now we're going to expand. This is the only hack I know, the only hack we know. So that's what we're going to use. We're going to go limit as x approaches 0, giant parenthesis, because we're going to have a product in there. And so here's where you need your color pencils. Right now, everything in red is original. I'm going to put a negative in the front, and then I'm going to move a little bit, and I'm going to put negative 1 times, and I'm going to go tan of 4x over one of the x's times, that's a squared, tan of 4x over another one of those x's times, let's see, what do I got left? Just that 36. And then put a 1 in the front. Giant parenthesis and close it. No, it's not squared anymore because I squared 6. 6 times 6 is 36. I don't have a squared. Where is the squared? X times x, guys. Yeah, what's wrong with it? 6x times 6x is 36x squared. That's what I'll put it up. Look, guys. Guys. 6x squared means 6x times 6x. 6 times 6 is 36. X times x is x squared. Come on, guys. Are we okay? Okay. No, guys. You guys have been doing squares since 7th grade. It's okay. Are we good now? What other questions, guys? Hit me. Okay. I don't see any issues. I think we're good. The x squared is the bottom and the bottom. X times x. That's my x squared. So I still have a 36x squared. Child, where does this negative 1 come from? I don't see that negative 1. That says negative in front of that. I could have left it as just negative, but I want it to be something, so negative 1. Are you guys okay with that? Okay, hit me, guys. Hit me.
Wait, that's applied to the whole thing.
Yeah, it's a product.
1 over 1.
Yes.
Okay.
Yes.
Wait, what possessed them to do it like that?
Oh, I need it. Okay.
Like, why did we do that?
The only hack I know is tan x over x.
So we just want.
So I want a tan x in the top and I want an x in the bottom.
Okay, that makes sense.
The only hack we know is tan x over x. Give me more questions. What other questions do we have?
So the logic is kind of like.
Guys, hit me. All right, so check it out. Do you have your colored pencil or a different color than E?
Yes.
All right, so right now I have tan 4x over x. That's not a 1 yet. What do I need in the denominator for tan 4x over x to be a 1? 4. Now, if you put a 4 in the bottom, what are you going to do in the top? You're going to put a what? Okay, here it is. Look, here it is. 4 in the bottom. Notice it's a different color. 4 in the top. 4 in the bottom, 4 in the top. It's a product. It's all a product. 4 in the bottom, 4 in the top. Just like chemistry. 3 oxygen on the right, 3 oxygen on the left. That's what you do in chemistry, right? When you're balancing. All right. I got another one. What do I need in the bottom for this tan 4x over x? If I put a 4 in the bottom, what do I put in the top? So here's my 4 in the bottom. Here's my 4 in the top. It's a product. As long as it's in the numerator, it's all a product, guys. I'm multiplying all the way. So as long as you see a 4 somewhere in the numerator. Are we okay still? Okay. I think we're good. Let's evaluate. Let's evaluate. So now, here's what I have. Equals, let's see, -1. That -1 is this -1. Times, what was tan 4x over 4x? 1. Times, what was tan 4x over 4x again? 1. Times, now I could reduce this. I'm going to reduce this. How many times does 4 go into 36? 9. So I have 4 over 9 because one of the 4's gotten eaten up. Or you can go 16 over 36 and then reduce that. Are we okay, guys? So what's -1 times 1 times 1 times 4/9? -4/9. There it is. That's my limit. That's as hard as it gets. It does not get harder than that. All right, here we go. All right, guys. Tomorrow we will work on activity 2 in lab because it's going to have trig limits, and I don't want you guys right now to go because there's too many of you. So in lab, when we separate you guys, that's the perfect time to work in little groups. So right now, all you're going to be doing is getting experience. Relax. I put all the easy ones. I just put the table ones, and I put the simple limits. And then if you're brave, you know enough to do the UH limits 1. I want an attempt by tomorrow. Notice I didn't put today. I put attempt by Tuesday, tomorrow. When is the due date? Next week. And let me go ahead and add to it. You see how we just did trig limits? You don't have enough experience, but there's a UH trig called Trig Limits. It's UH Quiz 5. If you want to get started in advance, you can do that already. Does that make sense, guys? All right, so what do I want today? Delta Math number 3. Please finish that today. If you still have time, I would like for you to make an attempt on UH Quiz 1, but you have until tomorrow to make that attempt. And then tomorrow in lab, we will go over that handout. Are we cool, guys? All right, let's get started. Let's get cooking.